We're going to solve another compound inequality, and I want to use this one to hopefully dispel the rumor that OR problems always look like this, and problems always look like, this. So, anyway, let's take a look at a couple more examples before we move on. Plus 8, by the way, it says to solve the compound inequality, and that's what we're doing. And so we have a 16, 4x, divide by 4, and x is less than or equal to 4. We have the OR. We have minus 3. We have negative x is less than or equal to negative 1. We're going to divide by a negative 1. When I do that, I have to flip the symbol, the inequality, and I'm going to get a 1. Okay, so I have x is less than or equal to 4, or x is greater than or equal to 1. Now I'm going to go ahead and put my number line down. I'm just going to label there the 1 there, and the 4 there, and now I'm going to do my prep work above it. So my first one is going to be anything less than or equal to 4. So this is what that's going to look like above. And then anything greater than or equal to 1 looks like this. Now, the word OR means either or, meaning put them both on, right? Both on there. And so I'm going to again do this dynamically, showing you, oops, I'm going to show you with movement what it really means. There's that one. OR means put them both on there. Whoops, come on. There we go. And so I slide them down onto the answer line, and that is my answer. Now, what do you mean that's my answer? That's wherever I see red, that's the answer. So if I go ahead and increase the thickness, wherever I have red is the solution. In other words, wherever I've colored, wherever there's coloring is my answer. So OR does not always mean that they're going to go in opposite directions like that. OR just means put them both on the answer graph. So in this case, the whole number line is colored, which means all real numbers. And now we want to write it in interval notation, which means we're going to make it negative infinity to infinity. So there's my graph, there's my interval notation. All right, let's take a look at the next one. Now this one has fractions, and I did that on purpose to just give you a little more practice with eliminating the fraction by multiplying by the reciprocal. So I think that's really the fastest way to take care of these, and it doesn't have to be a scary thing. So let's multiply both sides by negative 3 over 1, and principally because, if I go right here, get my little highlighter wherever it went, because, excuse me, this is what I'm trying to get rid of, right? I'm trying to get rid of that, and it's being connected to the x with multiplication. So I'm going to multiply by the reciprocal, and that's going to give me a big old 1 in front of x, and 1 times x is x. So that works. Now notice, though, that I multiplied by negative, so I'm going to flip the inequality, and that's going to be a negative 18. I'm going to leave the word and now I'm going to do the same kind of thing over here. I'm going to multiply by 5/4, multiply by 5/4, and I get x. And I didn't multiply by negative, so I'm going to keep the inequality going in the same direction. And that's really, that goes in there twice, that goes in there 5 times. So I'm going to get 25 halves, which is the same as 12 1/2. All right, so here we go with the number line. I have a negative 18, and I have a 12.5. Strange. All right, I have a 12.5. All right, first one, this one. Anything greater than negative 18. Anything greater than negative 18. Anything less than 12 1/2. The word and means the overlap only the overlap is where our answer is. So the only thing that we're going to color is this right here where there are double lines. Now that's a parentheses. It looks like a bracket. So this is what we're going to color. There's the answer, because and means only the overlap. So let's go ahead and write it in interval notation. So it's from -18 to 12.5, and that's my answer. Okay, I hope this helped to sort out this and or business. Thanks for watching.